In this video, we're going to look at differential equations. Now, it's not like applied maths where you have to create these, right? There's a lot of work involved in them. In maths, all we have to do is really substitute in and simplify to show that this differential equation is equal to 0. So we need the second derivative, we need the first derivative, and we need to multiply it by 4, and we need to multiply the original function by 4 as well, and that this should then equal 0. So separate, differentiate each. X goes to 1, e to the power of minus 2x goes to minus 2e to the power of minus 2x. So dy dx is equal to the first by the second differentiated plus the second by the first differentiated, which is just 1. So in this case, we have e to the power of minus 2x in both. So e to the power of minus 2x, and that's going to leave me with just 1 minus the 1 from here, and we have minus 2x times the other one. So that's dy dx. So now we have another product rule. So we got to do the same thing again. So differentiate both. I'll change colors for this part. Differentiate both. E to the power of minus 2x again goes to minus 2e to the power of minus 2x. 1 minus 2x just goes to minus 2. So now we have d2y dx2 is equal to the first, which is e to the power of minus 2x by the second differentiated plus the second, which is 1 minus 2x by the first differentiated, which is minus 2e to the power of minus 2x. Simplifying down, we're going to get minus 2e to the power of minus 2x. 1 times this guy is just going to give me this guy. So minus 2e to the power of minus 2x. And then we're going to have a minus by a minus, which is a plus 2x times 2e to the power of minus 2x. So what do we have? We have 2 minus 1, so we have minus 4 to them, minus 4e to the power of minus 2x plus 4xe to the power of minus 2x. So there's a 4e to the power of minus 2x in both. So let's factor that out. 4e to the power of minus 2x is going to be a minus 4. Sorry. A 1 just for this guy, an x for this guy, and a minus 1 for that'll be minus 1. Okay, if we sub these in, this is d2y dx2. So we sub them back in up here. We have our values, just let's keep them visible. So we have, bring this one down here, 4e to the power of minus 2x by x minus 1 plus 4 times dy dx in here, which is e to the power of minus 2x times 1 minus 2x, and the last part is 4 times the original function, which is x e to the power of minus 2x up here. So that's going to be plus 4x e to the power of minus 2x. So we just got to simplify this down and show that it equals 0. Now it looks like we have 4e to the power of minus 2x. We have the same here, and we have the same with these two parts. So I can factor out 4e to the power of minus 2x. I'd have to multiply it by x minus 1 to get this guy, and then plus 1 minus 2x to get that guy, and then plus x to get this guy in here. And that's going to give me x plus x is 2x minus 2x is 0, as is 1 minus 1. So we end up with 4e to the power of minus 2x times 0. which is equal to 0, 0 equals 0, quad erat demonstrandum. In this one, there's a little bit less work. Show y is equal to cos 3x is a solution to this differential equation here. D squared y dx squared plus 9y equals 0. So we don't need dy dx, we just need d2y dy dx squared. So we do need dy dx to get that. So dy dx is equal to cos 3x goes to minus sine 3x times 3, which is minus 3 sine 3x. So d2y dx2 is going to be minus 3 cos 3x times 3, which is minus 9 cos 3x. So let's have a look. How does this work in relation to our, well, we can see what's going to happen here. We're going to get 9 times y, which is 9 cos 3x, and we have a minus 9 cos 3x. So you can see the answer appearing here. Therefore, we get minus 9 cos 3x plus 9 times cos 3x equals 0 from here. So minus 9 cos 3x plus 9 cos 3x is equal to 0. 0 equals 0. And I love saying quad erat demonstrandum. Let's look at the next question. In this question, you're asked to show that f of t is equal to e to the power of 3t is the solution to the differential equation. I don't know why I have such difficulty saying the word f double prime t we need, f prime t we need, and we have f of t in the original equation. So f prime t is equal to e to the power of 3t times 3. And we can put the 3 in front, 3e to the power of 3t. F double prime t is 3e to the power of 3t times 3, which is 9e to the power of 3t. So something that looks quite difficult can actually be quite easy. So we end up with 9e to the power of 3t minus 6 times f prime t, 3e to the power of 3t. And we have plus 9 times the original e to the power of 3t. So that's going to give me 9 and 9, 18e to the power of 3t minus 18e to the power of 3t is equal to 0. 0 equals 0. And you can say it this time. In this one, we'll finish with this one. They're straightforward enough. They all follow the same kind of process. So if you can do these ones, you can do any of them. Show x e to the power minus x is a solution to, we need d squared y dx squared. We need dy dx, and we have the original. Now this is one of my predictions for, if you're watching this video before LC 2021, be prepared. This is coming up. So we have a product rule. Y is equal to x e to the power minus x. So the first differentiated is 1. And the second differentiated is e to the power minus x. Now, there is a number in there that we don't see. It's a minus 1. So times minus 1, which is minus e to the power minus x. So just be careful with this one. So dy dx is equal to the first by the second differentiated plus the second, which is e to the power minus x, by the first differentiated, which is 1. So we're going to get minus x e to the power minus x plus e to the power minus x. And we can obviously factor out our e to the power minus x. Now it's going to be minus x plus 1 or 1 minus x. Probably better putting the plus number first in the bracket, but it doesn't really matter. Okay, second derivative, e to the power minus x again goes to minus e to the power minus x. Second one goes to 0. No, it doesn't. It goes to minus 1. So d2y dx2 is equal to the first e to the power minus x by the second differentiated, which is minus 1, plus the second, which is 1 minus x, by the first differentiated, which is minus e to the minus x. Okay, let's tidy it up. So we're going to get minus e to the power minus x, and we have 1 by this guy, which is another minus e to the power minus x, so we have 2 of them, and we have plus x e to the minus x. So we've minus 2e to the minus x plus x e to the minus x. So we have e to the minus x times x minus 2. Okay, let's sub it back in. What are we looking for? We're looking for this one here. Twice dy dx y. So the second derivative, we'll write it out again. d2y dx2 plus twice dy dx plus y has to be equal to 0. So we have e to the power of minus x times x minus 2 plus twice dy dx. What do we get for it? This dy dx here. E to the power of minus x times 1 minus x. E to the power of minus x times 1 minus x. That's twice that one. And then we have plus y. And y was the original function, which was x e to the minus x, x e to the minus x. So we factor out e to the minus x. We have to multiply it by x minus 2 to get the first one. Here it is here, so I gotta have a 2 by 1 and a 2 by minus x, so plus 2 minus x, minus 2x even, 2 minus 2x, and then this x as well in there. Is that equal to 0? E to the power minus x times, yes it is, be 2x minus 2x and 2 minus 2 equals 0, 0 equals 0, and I'll give you all the pleasure of saying and my 6 years have also taught me to say like and subscribe and smash that subscribe button, whatever that means in modern young person's language.